Hey everybody, we are going to do the notes page for squares and square roots. So the very first thing on this page of notes is two definitions. And I'm going to read through them, but I'm going to explain them to you a little bit better once we actually do an example. So on the left, we have a definition that says a perfect square is the result of multiplying an integer by itself. And you may already know some perfect squares from 6th or 7th grade. I know in Virginia, in 1 year, you have to memorize a bunch because you can't use the calculator on this part. But even if you don't know them, no worries. The second definition says a square root tells us which integer was multiplied by itself. So this is just sort of doing the opposite. But again, that's going to make more sense once we see our first example. So if you are in the Benson-Voss class, the day that we do this activity, we're actually going to give you a bunch of square tiles and you're going to create perfect squares. But if you're not in our class at that time, no worries. You can just do a picture, which is what we're going to do in the notes anyways. So any perfect square is going to work for this. I'm going to make a perfect square. Now, I am drawing this just by hand, so I don't know how perfect it's going to be. But instead of just saying that that's a square, I'm going to divide it up into a bunch of little tiles like the activity that we're doing in class. So I'm going to make my square look like this. And you can adjust yours and make it a little bit different. And again, it doesn't need to be perfect, but hopefully you get the idea. If you had 16 of those little tiles, you could make a perfect square. And we know it's a square because each of the sides is the same length. Across the top, it's 4 blocks. Across the bottom, it's 4 blocks. On the left side, 4. And on the right side, 4. If you wanted to do a 3 by 3, that would take 9 tiles. If you feel like drawing a little bit more, you could do a 5 by 5. That would take 25 tiles. But this is going to answer our question perfectly because now we're going to use those two definitions. The perfect square in this picture is how many tiles we had to use to create this shape. So in this case, it's 16 because I have 16 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if you remember, the definition of a perfect square was the result of multiplying an integer by itself. And in this case, we're doing 4 times 4 is giving us 16. And 16 is that perfect square. Now, the square root of that, we can also tell from the picture. So the square root of 16, in fact, I'm going to write that with a symbol down here. We'll talk about that symbol in a minute, but if you already know it, the square root of 16 is however long each side is. So since each side is 4 blocks long, that's the square root. And if you look at that definition, a square root tells us which integer was multiplied by itself. Well, what do we have to multiply by itself to get 16? 4. Okay, so that takes care of that little reminder of what squares and square roots are. Now, let's do the next step. And the next step for 8th grade is to evaluate each expression. But in 8th grade, we have Desmos for everything. So if you look over here on the right side of the screen at Desmos, I can type in 3 and then I can go to this a squared button and click that. Okay, so that was right there. And that gives me my answer of 9. Now, there are other ways that you can do this also. You can also use a keyboard shortcut, or you can use the button right next to the one that we used. So if I type 3 and then it's Shift and the number 6 on your keyboard, it will do the same thing as this A to the power of b button, and it will just make your cursor go up there ready to type an exponent. So now I can put the 2 and I get the same answer. Okay, so let's put the rest of these in. 5 squared, 11 squared, which is how we would read that exponent of 2. We would probably just say squared because that's the quickest, easiest way to do it. And those will give me my answers: 25, 121, 361. So again, that's the same as doing 3 times 3, or 5 times 5, or 11 times 11, or 19 times 19. And then the other side of that is the opposite. So we can use the square root button right here, 81, and use that to get our answer. Or on your keyboard, you can actually type S, Q, R, T. And as soon as I hit T, it's going to turn into a square root symbol or a radical sign, and then put in the 144. So whatever method works best for you, go ahead and do that. And remember, square root just means what number am I having to multiply by itself to get that number that's under the radical. So 9 times 9 is 81, so 9 is the square root. 12 times 12 is 144, so 12 is the square root. And then these last two are something you probably haven't seen before 8th grade. You do them the same way, you just have to remember to put the negative in front. So my answers for those are -10 and -16. We are almost done. There is one last thing that we do with square roots in 8th grade, and I've got a couple examples of that. So let's look at what happens when a square root isn't pretty. If you've already learned what irrational numbers are, amazing. Okay, this is just saying that some numbers are not perfect squares, and so their square roots are irrational. But if you don't know what the word irrational means yet, don't worry about it. We're just talking about when we put in a square root, like the square root of 5, and we don't get a pretty answer. Okay, so what we do in those cases is we decide what two consecutive numbers the decimal is between and which one it is closest to. And I'm going to use a number line to show you what consecutive means in this first example. So, first example is the square root of 29. And when I put that into Desmos, I do not get a pretty answer. I get 5.385164807. And then it actually keeps going forever. Desmos just can't show us that. So when we're trying to decide what two consecutive numbers that decimal is between, the most helpful thing we can do is graph that on a number line. So I know that 5.38 is a little bit bigger than 5, but it's less than 6. So I'm going to say it's right there on my number line. And then when you look at that number line and see what two numbers the dot is in between, that's what we're talking about. So when we want to know what two consecutive numbers the square root of 29 is between, we would say it's between 5 and 6. Now, that doesn't mean you have to have the number line every time. You might be able to look at that decimal and just know it's a little bit bigger than 5 and it's less than 6. But I do like it because it reminds you that it has to be two consecutive numbers. You can't say it's between 5 and 10. That's true, but 5 and 10 aren't consecutive. They're not right next to each other. So that's what that means. And then when we're deciding which one it's closer to, you can look at your number line if you did a really good job of plotting it, or maybe you just know 5.3 or 5.4 is closer to 5. And I think the easiest way to do that is to talk about rounding. So how do you know which number it is closer to? you would round it and it would be closer to 5. So I'm going to write that down real quick and then I'll be right back. Ta-da! There's my answer. When I round the decimal, it is closer to 5. And if you want to write that a little bit differently, that's fine. I'm going to move on to the next one, but if you need to copy that down, go ahead and pause. All right, last example. Evaluate the expression and plot the decimal on the number line. So this time we've got the square root of 279, which is 16.0, oops, 16.70. And I'm actually going to stop writing there. I'm going to be a little bit lazy this time and I'm not going to keep going. Okay, I'm going to plot it on my number line. So it is bigger than 16, not quite to 17. And then I'm going to fill in this sentence. The square root of 279 is between 16 and 17, but I know that if I rounded this, it would round up to 17 because of that 7 there. So I'm going to say it is closer to 17. And then that's pretty much it, y'all. That's pretty much everything you need to know for squares and square roots right now in 8th grade. Go back and rewatch any of that if it was confusing, and we'll see you next time.